facing a customer who refuses to pay a bill, it is important to address the situation methodically. The initial step is to establish clear communication. Contact the customer to discuss the situation calmly and professionally. It's important to explain your belief that the bill is fair and reasonable given the work completed. Prepare a detailed breakdown of all costs, specifically including the excavator's fee, the cost of materials, and the labor expenses. Next, offer resolution options. Clearly state that the excavator's fee is a non-negotiable item since it reflects the actual cost incurred to hire the excavating contractor. Express a willingness to compromise on other cost components such as the materials or labor costs, but stay within reasonable limits. Also, you could propose alternative payment structures, such as setting up a payment plan or suggesting splitting the difference between the price you billed and the cost the customer was expecting. It is vital to emphasize the value and quality of the work you have performed. Highlight how the work met all required utility specifications and involved an upgraded electrical system. Reiterate that the work adhered to professional standards, met all relevant codes, and prioritized safety. Remind the customer about the deposit they made. The deposit amount they provided, in this case $500, can be presented as sufficient to cover the excavation costs. Propose applying the deposit to the outstanding balance and then request payment for the remaining material and labor expenses. You should be willing to negotiate within reasonable bounds while also establishing clear boundaries based on the actual expenses you have incurred. Make it clear that you cannot afford to work at a loss or provide services without compensation. If direct communication fails to produce a resolution, consider seeking mediation from a neutral third party. Alternatively, you could seek guidance from an attorney. After any agreement is reached with the customer, ensure you follow up by documenting the terms in writing to prevent any future misunderstandings. To maintain a constructive dialogue, maintain a calm and professional demeanor. Show empathy towards the customer's perspective while respectfully asserting your position. Maintain thorough records of all communications and expenses associated with the project. In the future, consider always using formal contracts to avoid similar issues. Let's discuss specific aspects of the electrical work performed. The trench that was excavated, measuring 40 feet long by 3 feet wide by 2 feet deep to meet utility requirements. Installing a 3-inch Schedule 40 polyvinyl chloride, or PVC, conduit from the utility transformer to the 100 amp meter base. The installation of an 8/16 space 100 amp main breaker service panel. The installation of 320 amp branch circuits and 130 amp branch circuit. Providing branch circuits to support future heating and air conditioning systems. Now let's get into some things that relate to electrical. Firstly, let's consider the service panel. A 100 amp service panel indicates the maximum amount of electrical current the panel is designed to handle safely. The 8/16 space specification refers to the number of breaker slots available in the panel. In this case, there are 8 main breaker spaces and 16 spaces where branch circuit breakers can be installed. It's essential to select a panel that provides sufficient capacity for current and future needs. Secondly, branch circuits. Branch circuits are individual circuits that supply power to specific areas or appliances. A 20 amp branch circuit is commonly used for general lighting and receptacle outlets. The National Electrical Code, or NEC, typically allows a maximum of 12 outlets on a 20 amp circuit, but local codes can vary. A 30 amp branch circuit is typically used for higher power appliances such as electric water heaters or electric ranges. The size of the wire used for branch circuits depends on the ampacity of the breaker protecting the circuit. The NEC provides tables such as Table 310.15b16 that specify the allowable ampacities of conductors based on their insulation type and temperature rating. For example, a 20 amp circuit typically requires 12 American wire gauge or AUG copper wire with THHN insulation, while a 30 amp circuit may require 10 AWG copper wire with THHN insulation. It is crucial to consult the NEC and local codes to ensure proper wire sizing and overcurrent protection for all branch circuits. Thirdly, the National Electrical Code, or NEC, sets the standard for safe electrical installations in the United States. It is essential to adhere to the NEC and local codes to ensure the safety of people and property. The NEC covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment installation. Local codes may amend or supplement the NEC to address specific local conditions or requirements. Fourthly, grounding. Grounding is an essential safety measure in electrical systems. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and clear the fault. The grounding system consists of the grounding electrode conductor, the equipment grounding conductor, and a grounded conductor. The grounding electrode conductor connects the grounding electrode, such as a ground rod or water pipe, to the service equipment. The equipment grounding conductor provides a path for fault current from the metal enclosures of electrical equipment back to the service equipment. The grounded conductor, also known as the neutral conductor, is intentionally grounded at the service equipment. Fifthly, conduit. Conduit is a raceway used to protect electrical conductors. Schedule 40 polyvinyl chloride, or PVC, conduit is a common type of conduit used for underground installations. The size of the conduit depends on the number and size of conductors being installed. The NEC provides tables that specify the maximum number of conductors allowed in different sizes of conduit. When installing conduit underground, it is important to bury it at the proper depth to protect it from damage. The NEC specifies the minimum burial depths for different types of conduit and wiring methods. Sixthly, overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds their rating. Fuses are one-time devices that melt and open the circuit when the current exceeds their rating. The size of the overcurrent protection device depends on the ampacity of the circuit conductors. The NEC specifies the maximum overcurrent protection for different sizes of conductors. It is essential to select the proper overcurrent protection device to protect the circuits and prevent fires. Seventhly, wiring methods. The NEC specifies various wiring methods that are allowed for different applications. Some common wiring methods include non-metallic sheathed cable, armored cable, and conduit. Non-metallic sheathed cable, also known as Romex, is commonly used for residential wiring. Armored cable, also known as BX cable, is used in commercial and industrial applications. Conduit is used in a wide range of applications where physical protection of the conductors is required. Eighthly, bonding. Bonding is the process of connecting metal parts of an electrical system together to create an electrically conductive path. Bonding is important for safety because it helps to equalize the voltage potential between different metal parts, which reduces the risk of electric shock. The NEC requires bonding of metal water pipes, gas pipes, and other metal objects that could become energized. Ninthly, electrical safety. Electrical safety is paramount when working with electrical systems. It is essential to follow all safety precautions to prevent electric shock and fires. Always de-energize circuits before working on them. Use properly insulated tools. Wear appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Never work on electrical systems in wet or damp conditions. If you are not qualified to work on electrical systems, hire a licensed electrician. Tenthly, load calculations. Load calculations are used to determine the size of the electrical service and the size of the branch circuits. The NEC provides methods for calculating the electrical load of a building based on its square footage and the types of appliances and equipment that will be used. It is important to perform accurate load calculations to ensure that the electrical system is properly sized and can safely handle the anticipated load. 11thly, voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances and equipment to operate inefficiently or not at all. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The amount of voltage drop depends on the length and size of the conductor, the amount of current flowing through the conductor, and the conductor's resistance. It is important to select the proper size of conductor to minimize voltage drop. 12thly, arc fault circuit interrupters, or size. Arc fault circuit interrupters, or size, are devices that are designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. A size detects arc faults and interrupt the circuit, which helps to prevent fires. The NEC requires a size in many areas of the home, such as bedrooms, living rooms, and dining rooms. 13thly, ground fault circuit interrupters, or GFCIs. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against ground faults. Ground faults occur when current leaks from an electrical circuit to ground. GFCIs detect ground faults and interrupt the circuit, which helps to prevent electric shock. The NEC requires GFCIs in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. 14thly, surge protection. Surge protection devices are used to protect electrical equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronic equipment. Surge protection devices divert the surge current to ground, which helps to protect the equipment. It is important to install surge protection devices at the service entrance and at sensitive electronic equipment. 15thly, electrical inspections. Electrical inspections are performed by qualified electrical inspectors to ensure that electrical installations comply with the NEC and local codes. Electrical inspections help to identify potential safety hazards and ensure that the electrical system is installed correctly. It is important to obtain electrical inspections for all new electrical installations and for any modifications to existing electrical systems. 16thly, electrical permits. Electrical permits are required for most electrical work. Electrical permits ensure that the work is performed by qualified individuals and that the installation complies with the NEC and local codes. It is important to obtain electrical permits before starting any electrical work. 17thly, wire connectors. Wire connectors are used to connect electrical wires together. There are various types of wire connectors available, such as wire nuts, terminal blocks, and crimp connectors. It is important to use the proper type of wire connector for the application. Wire connectors must be properly sized for the wires being connected and must be installed according to the manufacturer's instructions. 18thly, electrical boxes. Electrical boxes are used to enclose electrical connections and protect them from damage. There are various types of electrical boxes available, such as metal boxes, plastic boxes, and weatherproof boxes. It is important to use the proper type of electrical box for the application. Electrical boxes must be properly sized for the number of wires and devices being installed. 19thly, electrical tape. Electrical tape is used to insulate electrical connections and protect them from moisture. Electrical tape must be rated for the voltage of the circuit being used. It is important to wrap electrical tape tightly and securely to ensure a good seal. 20thly, cable ties. Cable ties are used to bundle and secure electrical cables. Cable ties help to keep cables organized and prevent them from being damaged. It is important to use cable ties that are rated for the environment in which they will be used. 21st, multimeters. Multimeters are used to measure voltage, current, and resistance in electrical circuits. Multimeters are essential tools for electricians and electrical technicians. It is important to use a multimeter safely and correctly. 22nd, amp clamps. Amp clamps are used to measure current flowing through a conductor without having to disconnect the conductor. Amp clamps are useful for troubleshooting electrical circuits. It is important to use an amp clamp safely and correctly. 23rd, wire strippers. Wire strippers are used to remove insulation from electrical wires. Wire strippers must be properly sized for the wires being stripped. It is important to use wire strippers carefully to avoid damaging the wires. 24th, pliers. Pliers are used for a variety of tasks in electrical work, such as cutting wires, bending wires, and gripping objects. It is important to use pliers safely and correctly. 25th, screwdrivers. Screwdrivers are used to tighten and loosen screws. There are various types of screwdrivers available, such as flathead screwdrivers, Phillips screwdrivers, and Torx screwdrivers. It is important to use the proper type of screwdriver for the screw being used. 26. Fish tape. Fish tape is used to pull wires through conduit. Fish tape is typically made of steel or fiberglass. It is important to use fish tape carefully to avoid damaging the wires or the conduit. 27. Ladders. Ladders are used to access elevated work areas. It is important to use ladders safely. Always inspect the ladder before use. Set up the ladder on a level surface. Never stand on the top rung of the ladder. 28. Personal protective equipment or PPE. Personal protective equipment or PPE is used to protect workers from hazards on the job. Common types of PPE for electrical work include gloves, safety glasses, and hard hats. It is important to wear appropriate PPE for the task being performed. 29. Lockout tagout or loader. Lockout tagout or loader is a safety procedure used to prevent accidental energization of equipment during maintenance or repair. Lockout tagout involves disconnecting the power supply to the equipment and placing a lock and tag on the disconnect switch. It is important to follow lockout tagout procedures to prevent injuries. 30th. Confined space entry. Confined space entry is a hazardous activity that requires special training and equipment. Confined spaces are spaces that are large enough for a worker to enter but have limited means of entry or exit and are not designed for continuous occupancy. It is important to follow confined space entry procedures to prevent injuries or fatalities. 31st. Trenching and excavation safety. Trenching and excavation are hazardous activities that require special precautions. Trenches can collapse and bury workers. It is important to follow trenching and excavation safety procedures to prevent injuries or fatalities. 32nd. Overhead power line safety. Overhead power lines are a serious hazard. Contact with overhead power lines can result in electrocution or serious burns. It is important to maintain a safe distance from overhead power lines. 33rd. Underground utility locating. Before digging, it is important to locate underground utilities. Contact the local One call center to have underground utilities marked. This will help to prevent damage to underground utilities and prevent injuries. 34th. Working in hot weather. Working in hot weather can be dangerous. Heat stroke and heat exhaustion are serious health risks. It is important to take precautions when working in hot weather, such as drinking plenty of fluids, taking breaks in the shade, and wearing light-colored clothing. 35th. Working in cold weather. Working in cold weather can also be dangerous. Hypothermia and frostbite are serious health risks. It is important to take precautions when working in cold weather, such as dressing in layers, wearing a hat and gloves, and taking breaks in a warm place. These considerations, combined with the strategies for communication and negotiation, will help you navigate payment disputes and ensure fair compensation for your work.